Hello, Mr. Geislart here, and we're going to take a look at number 8 on the Unit 2 target packet. The reason why we're taking a look at this one is because it gives us a special property about isosceles triangles. And let's see if we can figure out what that is by working through this problem. The first question, or if we look at the setup rather, notice that in the setup we have a mirror that's reflecting a triangle. When you reflect something, it keeps the same size and proportion. So in the first question here, where it's asking to find the measure of angle A, B prime, C. The angle A, B prime, C is this angle right there, where the vertex is B prime. Because that's a reflection, it's going to be the same measure as angle ABC. So my angle here will just be 31 degrees. Now, if we want to find the measure of angle BAC. Now, these two angles are also equal to each other because they're a reflection. Because they're on a line, it has to add up to 180 degrees, so that means each of those are 90. So if I want to find angle BAC, which is this angle right here, BAC, I just have to take 90 plus 31, which is equal to 121, and then subtract that from 180. And when I do that, I'm going to end up with 59. So this angle up here is 59. Now, angle B prime AC. Well, B prime AC is this angle here. Again, that's just a reflection of this angle. So these two angles up here are reflections of one another, so this is also 59 degrees. Next, we want to find ACB. Well, we already know that's 90. We already figured that out. And ACB prime is also 90 degrees. Now, what is the length of AB prime? Well, side AB prime is the side over here. Well, that's just a reflection of side AB. So that is the same length. So that will just be 37. So if we write everything in here, all of my angles and all of my sides, we have a picture that looks something like that. Now, it says what kind of triangle is triangle ABB prime? So AB B prime is this triangle right here. That's like the big triangle. Well, since this side is 37 and this side is 37, that makes it an isosceles triangle. Now, the whole point of doing this is to recognize that in an isosceles triangle, the angles opposite of the congruent sides are congruent. Now, I'm going to erase a few things to make this look a little bit easier for us to see. Okay, so let's erase that. Okay, so now we know that this side over here is 37. I know that this angle is 31. So what it says is that the angles opposite of the congruent sides. So angle B prime is opposite of AB. Angle B is opposite of angle AB prime. These two angles are congruent. So if you have an isosceles triangle, the two angles opposite the congruent sides are congruent, which is what this is saying. So that's kind of the point of doing this problem, is to figure out and to demonstrate that property.